So let's begin with understanding the convex functions. So let's assume that there's a function f which is a mapping from an n-dimensional real vector to a scalar, a real scalar. So this function f is convex if and only if, number one, its domain, the domain of the function f, I should restrict it like same notation. Domain of the function f is convex set. And second, if there are x and y, for all x comma y that belong to the domain of the function, and any theta which is between 0 and 1, the following property or the following inequality holds. F of theta x plus 1 minus theta y is less than or equal to theta times f of x plus 1 minus theta times f of y. Right. In other terms, we can also write it as f of y plus x minus y times theta y plus x minus y times theta is less than or equal to f of y plus theta times f of x minus f of y. So there are two conditions. Number one, the domain of the function should be a convex set, and second, f should satisfy this inequality for any x and y in its domain and any theta that is between 0 and 1. So what does it graphically mean? So let's restrict ourselves to a scalar case. Let's assume that f is a mapping from a scalar, a real scalar to a real scalar. So this is x and this is our f of x, and let's draw any right. So if we select any 2 points in the domain of the function, and if we draw a chord between them, I should have drawn a more straighter chord, but you got the point. If we draw a chord between the points x comma fx and y comma fy, then this chord shouldn't intersect the function, shouldn't cut the function basically. This chord should either remain above the function or exactly equal to it, but it cannot cut this function. So this function is not a convex function. Whereas, let's take another example. If this is our f of x, x f of x, then if we select any 2 points x and any point y, then if we draw a chord between the 2 points, so this is a point y comma fy, and this is a point x comma fx. So the chord that goes from point x comma fx to y comma fy should either remain above the function or should be exactly equal to the function, but cannot cut the function. So any function that satisfies this property is a convex function. We can take another example. So let's take this function. So if we select any 2 points, then the chord between those 2 points is above the function and is equal to the function only 2 points. If we select these 2 points, for example, then also the chord meets the function at all these points, but it doesn't cross the function. So any such function that satisfies this property is a convex function. And now the natural question is, what is a convex set? Right? So let's consider, also just before stating what convex set is, f is strictly convex if f satisfies the following condition. If f of theta x plus 1 minus theta y is less than theta times f of x plus 1 minus theta times f of y for theta between 0 and 1. Note that this is an open set, 1 and 0 are not included. At 1 and 0 this the equality would hold. So for any theta between 0 and 1, if this condition is strictly satisfied, then f is a strictly convex function. Given the domain of the function is a convex set. So now the natural question is, what is a convex set? So let's consider we have a set S of some m data points, x1 up to xm. Then if we select any 2 points in this set at random, so if we select any 2 points x comma y that belongs to the set, then for any theta between 0 and 1, note that this is a closed set. The set S satisfies the following property, that theta times x plus 1 minus theta times y also belongs to the set S. So any set that satisfies this property is a convex set. So graphically, let's take this set for an example. Excuse me. So if we select any 2 points and we draw a line segment between them, then we can see there are many points on this line segment that are not inside the set. So that's why this set is not a convex set. Whereas this set, if we select any 2 points, the line segment between them is also inside the set. So every point in this line segment is also in the set, inside the set. So this is an example of a convex set.